Good evening, guys.
Good evening, James.
Hi, James.
Hello. Hi, how are you, my friends?
We are great, thank you.
All good. We're all good, James.
How was the festive?
The festive was fine. The festive was very, very fine. I hope you also enjoyed yours. All right,
Most
so
definitely. How's the boy doing?
the boy is fine. He's crying in his room there. But he's fine. He's very, very fine. All right. So today is basically our first day for the second semester, but we don't want to do quite a lot. We just want to look at a couple of very small things. So in essence, Koda?
Yes, James.
Yes, can you please record? Can you record for us?
It is recording.
Wonderful. Okay, that's fine.
Okay.
So what we basically want to do is just to introduce a particular subject. So officially, our classes will be starting on Monday. So that will be Monday, Tuesday, Wednesday, Thursday from next week. But there is a module called Statistical Techniques. That module is very long, and some students struggle with it a little bit because there's a lot of calculations within that module. So there's a little bit of theory that is found in the unit number 1 of that module, and that is what we want to have a look at today. Right, so we just want to look a little bit of theory for the statistical techniques module. However, during this coming weekend, I will send you the official timetable of when each module is going to be. Remember, there are about 5 modules. You chose 4 modules that you're going to do. We are covering all of the modules that you're doing in your second semester. So all of the modules are going to be covered. That's number 1. Then number 2, like we did last semester, we are going, please make sure you're muted, guys. All right, so like we did last semester, we are going to do the assignments within the class setup. So we will go through the assignments together, we'll go through the case study together, we'll go through the quiz together, and we will also go through past exam papers together. So that's one of the reasons why we want to start early, so that we can finish early and go through the past exam papers. So the same model of operation that we were using last semester is the same model of operation that we will be using this semester. Then in terms of the tutors that will be taking you, I will introduce them as they come through for the different classes that you're going to be doing. All right, so that's essentially the overview of it. But in terms of the timetable of which class, which date, I will send it through this coming weekend. I'm just confirming there are two guys that are supposed to take two other modules. I just want them to confirm the time and the dates before we post the official timetable. So for today, we are looking at statistical techniques. Statistical techniques, these are calculation. This is statistics. So we have got Mr. Svanda, who is going to be taking us through this particular module. He's very good at teaching mathematics, he's very good at teaching statistics and quantitative modules. So I've selected him to take you through this module because it's much, much better than I can in terms of calculations for stats and etc. So Mr. Svanda, I believe you have the floor. I will see you guys next week on Monday when we start all the other modules together. Mr. Svanda?
Thank you so much, Mr. James. So like Mr. James said, my name is Kuda. So I'll be the one taking you for this module, statistical techniques. So today we're just going to start with the first, slide that will cover a little bit of theory before we get into much of the calculations. So like James said, this is a mathematical module. So it doesn't have a lot of theory, but there's a lot of calculations that are in this module. But there's a way that I approach this module. So what I do normally is I assume that no one has a background of or someone saying, please record the session. Yeah, it's being recorded. We are actually recording the session right now. Thank you for the reminder. So normally what I do in this module is I assume that all of you don't have background in statistics, so that we can cater for those that didn't have that background of stats. So I'll try to explain all the formulas from an elementary point of view, right? So I'll try to make it as simple can be, so that all of us can be on the same page. And I try by all means not to go to the next level until we have everyone on board. So today basically is more like just trying to show you how I do the lectures, my mode of delivery, and also explaining the basics of the module. So feel free to ask a question. Don't wait until I finish everything, all right? Whilst I'm actually explaining a certain concept, if you have a question on that, whatever that we're discussing, kindly unmute and then ask, or maybe you can write on the chat. I'll try by all means to address to that. So I'll also be looking at the chat, to make sure that I don't miss anything here. Okay, let me see. What am I? Okay, what am I showing? Can you see? Just give me a moment here. All right, I have a second screen, so I think let me just. All right. All right, so I'm assuming that all of us you can see. Let me see. Just confirm with me if you can see the slides.
Yes, we can see the slides.
All right, perfect. All right, so what we're going to do, we're not going to cover everything that is listed on the overview of this lecture. But what we're going to do, we're going to start with explaining what statistics is, the type of statistics, and then we're just going to get into something that will give us background for us to get into the calculations. Like I said, this module is mathematical, so 95%, if not 98% of everything that you're going to get, it's going to be mathematical. So we want to spend time on that. All right. So let me start by explaining what statistics is all about. So statistics, it's all around us, right? Especially for people that are into management or doing things that are related to management. So whether you talk about income, whether you talk about profit, whether you talk about um, whether you talk about turnover or you talk about levels of production, right? As long as it's something that is involving numbers, right? Then there's statistics. So statistics is basically numbers. When you see numbers, especially in the business sector, right, there's going to be statistics there, right? So statistics, basically, it is a way of, one, gathering the data. Two, you organize that data. Three, you interpret that data so that it will make sense to the other people you are presenting that data to, so that it also helps you to make good decisions. So the reason why, because some of you people might wonder, why are we doing statistics when it's a business module, right? So remember, you're doing advanced diploma in business management. So you are aiming for a managerial role. Managers, what they do is they make decisions. You don't make decisions by instinct. All right. So in business, you don't make decisions by instinct, but sometimes instinct can be wrong. But you want what is called an informed decision. I don't know if you have heard something like that, informed decision. So you want to do what is called informed decision making. So statistics, that's where it comes now. It helps you to inform you with certain information that can either verify or contradict, maybe contradict or maybe the decision that you want to make. So let's say you want to change a strategy. Maybe the current strategy that you are having, it's affecting sales, right? So now you have to prove that the current strategy is not working. So one of the ways to prove that is to collect data, let's say from sales, and then you do statistical modeling. And then that modeling, the results when they come out are the ones that are going to tell you whether the strategy is working or not. So it's very, very important to understand what we call statistical reasoning, right? And you should be able to interpret the results accurately, right? So, like we said, statistics, you gather data, you organize data, you classify, you summarize, you interpret, and then you draw conclusions from the data. So what it does is it facilitates what we call the informational presentation of data to support decisions. So now you're using statistics, like what I said, to support a decision, right? So you'll be referring to a range of techniques, procedures of analyzing, interpreting, displaying data in order to make decisions based on the data. So the key word there is you're using statistics to make an informed decision, right? So that's the reason why statistics is part of your module. Now, statistics is now divided into two, all right? So there's what we call descriptive statistics, and there's what we call inferential statistics. Now, descriptive statistics the name itself is more like self-explanatory. So it's statistics that is used to describe data, right? So it's either you summarize data or you describe data. So that's the type of statistics which is called descriptive statistics. So basically what you are doing with descriptive statistics, you summarize the data and you describe the data using what we call, whenever you see frequencies, whenever you see, let's say, percentages, when you see something like mean, average, or maybe get something like a median, right? Or standard deviation or variation. We're going to get into that. I'm just giving an example of maybe some of the words that you have come across. So these are types of statistics that describe data. So you are describing data using one value. Let me take an example, an average, right? So when a lecturer gets into a lecture room and says, what is the average shoe size of the people in the room, right? Apologies for that. So so the lecturer comes and says, what will be the average shoe size of people in the room? So what they do is they do average. I think all of you know how to do an average, right? So they write down the shoe size of each and every person, and then they find the average. So what the average does is the average describes the shoe size of everyone in the room. So you say the average shoe size of these people is 7. It's like when schools say our pass rate is 90%. It doesn't mean that everyone got 90% or whatever, but what it means is they did an average of all the people that wrote, let's say, a matric, right, that year. And then they saw that, if we have combined all the marks and average them, it's 90. So you are describing the pass rate of a school using one value. So you are describing. So that's the whole point of descriptive statistics. It's statistics that is used to describe data. So you're describing data using a single value. Not single value all the time, but most of the time. Then there's what we call inferential statistics. Inferential statistics now, what it does, it generalizes data about a population or makes inferences, right? So what it does, let me give you an example. So let's say there's a person who wants to understand what is the relationship between employee satisfaction and organizational performance, let's say in the financial sector. So they are looking at a company which offer financial services, but they want to understand what is the relationship between an employee being satisfied at work and how that satisfaction, how does it affect organizational performance? Now, this person can't go to each and every financial company in South Africa. We don't even know how many financial companies are there in South Africa, right? There are so many. So what this person does, he says, okay, what I'm going to do, I'm just going to take a sample of financial companies in Gauteng province or whatever province it is, or maybe whatever city it is, right? So let's say they take 30 companies and then they do that research and then they get the data. When the data comes, remember, they took 30 companies out of all the companies in South Africa. But when the data is interpreted, it's interpreted as all of the financial companies within South Africa. So what they are doing is you are generalizing statistics about a population using a sample. This is where inferential statistics comes in. So you are just generalizing the whole population, but you don't do the study or the research on each and every component in that country, but you just take a sample and use that sample to generalize on everyone else. So those are the two types of statistics that we have. Now, when you are a manager, right? Remember we said statistics is a tool that is used, right, by managers when they want to make decisions. So one of the things that you need to understand as a manager is the way you present data is very important. Because if you want to show certain people certain information, especially which is statistically based, the way you present the data is very, very, very important. All right? So the information obtained from a statistical analysis is meaningful to business managers only when it can be interpreted and communicated effectively in science. So if you get, let's say, results, right, from a statistical modeling or statistical analysis, if you cannot interpret and if you cannot communicate it, then it defeats the whole purpose, because we are saying statistics is a tool we are using, right? So if you are not able to know how to use the tool effectively, then it's going to be a problem. So it is customary to convey such information through the use of summary tables or charts. I think some of you guys have seen when you go on board meetings, when people are discussing certain things, they come with charts, they come with tables, right? That is statistics right there. That's why I say statistics is all over, right? It's only that when people see the word statistics, they try to, to imagine complicated things, right? But when you're in a meeting, you start to see some charts, you start to see some tables right there, right? That's statistics, as long as it involves numbers, right? As long as it involves numbers, then that's statistics. So tables and charts, they convey information more vividly and quickly than written reports. So one of the reasons why you see people when they're doing their slides, right? Okay, let me try. I think some of unmuted. Guys, just make sure, for the sake of the other guys, just make sure that you mute yourself so that we won't have some problems. All right. So the reason why people use tables and charts is because a table and a chart, it communicates information more vividly or more clearly and quickly than written reports. I've got the next slide is going to show you what this statement means. So one such compact and efficient way of presenting data is in form of a table, right? So you don't want to be reading information. That's why you see people that do, presentations, they try by all means not to be just reading, right? They need to show certain things on the screen so that, they can catch the audience. So using a table to list data according to category is often much clearer than writing out all the information in paragraph form. So when you put a table, it's better, right, than putting a written information in a written form. Look at the two examples there. So this is what I call the beauty of using tables, right? The beauty of using tables. So you can see right here, right? You can see, okay, let me just do something here. All right. So you can see on the right here, right, that we have written information. Even trying to read this, you just feel lazy, right? Because I can't even read, I can't even see what's happening here. So I have to read. Maybe it will take me 2 minutes just to read this whole paragraph for me to understand. But watch this. The same information on the left side is the same information that is on the right side. Right? But if I am just looking at the table, I can have an idea, even if the person does not explain to me. So I can see right here that, oh, okay, so these are institutions. Oh, okay, so these are what? Their ranks, right? Oh, and these are the holdings maybe that are associated with research libraries, right? So basically, you can get to understand that, oh, okay, so this is the information there. But just imagine on the left side, it will be much harder to comprehend such information, especially when you are trying to present it to your fellow board members, all right? So it would be way better to find a way of displaying that information in a vivid and more clearer way. And tables is one of those. All right. So let's look at maybe two main tables that we're going to look at when we are doing the calculations, right? So there's something called a frequency table. So a frequency table, remember, for now we're just doing the theory part of it. Then maybe from next week going onwards, then we get into the calculations. So the frequency table, it shows the number of occurrences of a variable falling into a specific range or category. So before I explain this, let me use this example that I normally use. So let's say you are in a lecture room, right? The lecturer comes and then he says, okay, remember we're talking about shoe size, right? So he comes back again and then he says, all right, we want to group people based on their shoe sizes, right? And then the lecturer says, those that have a shoe size of, let's say, 3 to 4, right? Can you stand and go to this corner? Then he says, those with 5 to 6, can you stand and go to that other corner? 7 to 8, can you stand and go to that other corner? So he's grouping all the people within the room based on certain classes, based on certain ranges, based on certain categories, right? So now when you are trying to display that type of data where you are bundling people or where you are grouping people together, you use what is called a frequency table. So that's why the definition there says a frequency table shows the number of occurrences of a variable. In this case, it will be the number of people with a certain shoe size that falls into a specific range or category, right? So you use a frequency table, right, to group such people. So an example that is within your study guide, it says consider a group of 47 males of various ages. 12 are between 20 and 29 years of age. 13 are between 30 and 39 years of age. 7 are between 40 and 49 years of age. And 8 are between 50 and 59 years of age, while the rest are between 60 and 69 years of age. So can you see, this is the same information, but it's in word format, and it might be hard to comprehend. This same information on the left side is on the right side, right? That's why I was saying the beauty of using a table. So now you can quickly comprehend it. So you're saying we've got a column, all right, or a row in this case. So it's an interval, which are the years of the males and the number of males that fall into that bundle or category. So between 20 to 29, we have 12. 30 to 39, we've got 13. 40 to 49, we've got 7. 50 to 59, we've got 8. 60 to 69, we've got 7. So the good part of it is each and every person will have a class that they fall into. You take into account everyone. That's why you see when you add all these values here at the bottom, 12, 13, 7, 8, and 7, you get 47. All right? Because you are taking into account everyone else. So when that table is there, immediately we can make these conclusions. One, you can see there that the majority of males are young, that is below 40 years of age. So if you define that young is below 40 years of age, we've got two classes that are below young, which is 20 to 29 and 30 to 39. If you add these two, you will see that this is where the major number of the people are. So that's why I'm saying majority of males, right? Then you can also tell that most people in this group of males, their years are between 30 to 39. Why? You look at the class with the highest number. So in this case, it's 13. So it means most of the males in this group, right, their age was 30 to 39. Then when you add now all the individual number of the males from each group, it will come to the total number, which is 47. So this is an example of a frequency table. Then there is now a frequency table that has what we call a twist, or that has got what we call a modification. All right. So let's look at an example. Consider a class. This example is there in your study guide. So consider a class consisting of 100 students. Is that a question? Okay, someone's asking what is the name of the module I joined. So this is Statistical Techniques, ADBM, right? Advanced Diploma in Business Management. So it's Statistical Techniques. So that's the name of the module. So it says, suppose the teacher gives the entire class a statistics test, which has a maximum mark of 100. Upon marking the scripts, right, which are in no order whatsoever, he puts the marks into a table as shown below. This represents raw data since there is no set or order of the marks. So we are going to talk about raw data later on, defining what type of raw data, what raw data is and why is it different from grouped data, all right? So these are the marks of the people that wrote let's say, a statistics test. There were 100 of them. So this was just put for record keeping. So if you check, you will see that the maximum number is 90. I'm not going to, obviously we have to check manually from each column and each row, right? Each cell. So the maximum value will be 90 and the minimum value will be 8. So you can actually calculate the range. We are going to talk about the range later on when we get to measures of dispersion. So now what we want to do is, let's see where the cumulative frequency table comes in. All right. So now when you are creating what is called a cumulative frequency, when you are given data like the previous one, what you need to do is you need to be able to group the data, right? You need to be able to group the data. So like, for example, here, when you have your intervals, we're going to show you how to create some intervals and and to group them when we start like the calculations themselves. Here I'm just, explaining, giving an overview. So let's say you already have your classes here, 0 to 9, 10 to 19, up until 90 to 99. So when you want to group them, you need to go back and say how many people got a mark between 0 and 9. So now you have to come through each and every cell, and then you get this value there. You will see that is the only value that is between 0 and what? 0 and 9. Then you come and you record. It's one person. Then you go again, how many people fall into the mark category of 10 to 19? You come and you check, right? You count them, and then you see that there are 2, right? Then you go back again, you count how many people fall into the range mark of 20 to 29, right? You count them again, you see that there are 5. So you keep doing for each and every class, right? When you populate all of the classes, if you add them, you will see that it will give you the total number of people. So basically, when you are grouping people, you are not eliminating certain people, you are not adding more people. You are just grouping the people that are already there, but you are grouping them based on a specific category. In this case, it will be like a mark, right? It will be like a mark. So after you have your frequency, so that's how you calculate your frequency there. Then there's something called cumulative frequency. So there's an example that I usually love to use, right? It may look a bit weird, but but at the end of the day, like I said, we want each and every person to understand, all right? And my assumption is some of you people might not even, you may not have heard of these terms before. So I'll try to explain them in a much more simpler way. So let's take these individual classes as houses, right? So let's say these are houses, maybe in a township or wherever, right? Or whatever suburb, right? So this arrow here represents a person, right? So this person is moving from one house to the other, right? So let's forget that it's called trespassing, right? For the sake of explaining, let's just assume that this is possible. A person to move from one house to another. So let's say these frequencies are representing stones, right? Individual stones within a household. So when a person is, before he enters the first house, he has or she has 0 stones, right? Then when they get to the first house, they collect a stone. So that stone will be put on the first cell of the cumulative frequency. Then when they get, so they take the stone and put it in a bag, right? Then they go to the next house, they collect the stones at that house, which are 2. When he puts those stones in that bag, the total number of stones become 3, right? Then when they move to the next house, they collect the number of stones there, right? And then they will still be adding into the bag. So the total number of the stones will be 8. When they go to the next house, when they collect these stones, the total number of what? Of stones will be 14. Go again, 29. The number of stones will be. So as they are moving from one house to the other, right? Up until they get to the last house, they are taking all the stones together. So what it means is after they leave the last house, the total number of stones, right, would be the total of all the stones of all the houses combined, right? So basically what you're doing is, that's why it's called cumulative. You're accumulating the frequencies as you move from one class to the other. So from the first class, the first class has got 1 frequency. The second class has got 2 frequencies. So when you add these 2, you get 3, right? Okay, let me try to mute. Right. Then when you move to the next class, which is 5 here, if you add 1 plus 2 plus 5, you get 8. When you move to the next class, which has 6 here, if you say 1 plus 2 plus 5 plus 6, you get 14. So right now it might look a bit harder, but I have more like some Excel sheets and some websites that will make life easier for you. So most of the things we're going to, we won't be doing it manually that much, right? But I'll be showing you shortcuts of actually, presenting certain things from your module so that it will make life easy for you. So right now it may look a bit difficult calculating this, but when we do the actual examples, when we are using Excel sheet, you'll see that it's very, 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 very important. So this is how you make a cumulative frequency. So a cumulative frequency now, it is used, you make it when you want to, let's say, cumulate the frequencies. So it is used, this is used when you are doing further calculations, right? When you are doing further calculations, more like when you are now doing your median mode, we're going to get into that. So you will need some of the things that come from the cumulative column, cumulative frequency column. So now that we are done with the table, so basically those are the 2 main tables that you need to know for now, right? For now, that are very, very, very important. The other tables that are going to meet, they're just tables that are there just to report the data. But these ones have got a specific format that they are created, and they are very, very useful when we are calculating what we call managerial statistics, right? We are going to get into that a bit, I think, in a couple of lectures to come. So now let's look at another way of presenting data. So we said there's tables, right? And now we are looking at graphs and charts. Remember, tables and graphs and charts, they are good than showing written format. But however, a table has its own flaws, right? Its own problems. A table is a useful way to present detailed data, but a picture or a diagram is more powerful if we want to focus attention on a particular aspect, such as a dominant feature or a trend, right? So let's say if a company is operating at a profit, you can't display that on a table. our company has been operating at a profit. Look at this table. People will be looking at you and be like, what are you saying? Right? Because it's harder for people to try to visualize a trend from a table. Right? So you need now either a graph, preferably a line graph, right? Or what is called a trend line. A graph which is a line. So at least people can see, oh, okay, the line is increasing. So that represents increase in profit, right? If you want to show a dominant feature, so let's say we are operating at a, let's say it may not be profit that is going like directly up, but maybe it's fluctuating, right? You may want to show the dominant feature and say this month is the month where we had the highest number of sales. So maybe that month was in the middle of the year, right? So obviously when you draw a graph, it will be more like a V. Is it a V or an upside V? Yeah, an upside V, something like that, right? So that it will show a dominant feature. So a graph or a chart will be better off to display these things. So there are many different types of graphs we can use to portray the data. So we've got what we call a line graph. We've got what we call a bar graph. We've got what we call a pie graph or a pie chart. So let's start with a line graph. So one method of showing trends or comparative trends is to use a line graph. So when you want to show a trend, the go-to graph is a line graph, right? It's a good example. So a very good example is, let's say you want to show the growth or the profit of an organization. So this company has been operating from 1997 to 2002. So we can see these values there. It will be harder for us to of course, here when you see that it's descending, but let's say maybe there were some other values that were now bigger than the first one. Maybe it came down and then shoot up again and then came down. So it will be very hard for you to visualize the trend from a table, right? So this same data on a table is the same data on the right side. But you can see that if a person sees the diagram on the right side, definitely without a shadow of doubt, without even interpreting much, they can say, Eish, by just seeing the axis, a profit there, yeah, there, they'll be like, yeah, you've been operating at a loss. You see. So using this type of a graph, using this type of a chart, right? It will be easier for you to communicate your information. So a study of the table shows that the profits have dropped considerably. This trend can be better depicted using a line graph. So that's the other thing of statistics. When you're communicating something, know what to put, which can easily convey the message. Right? That's why I'm also taking time to explain this. It might be stuff that you already know, but like I said, we approach this module from an elementary point of view, right? So now there's a bar chart. So a bar chart is another way of presenting data, but instead of drawing a line, you present it in terms of a series of bar. So the larger the bar, the more the magnitude. So if it was profit, it means that these bars that are much bigger, it means these are the years where we had more profit. And then these are the years maybe the company struggled a bit. All right, it struggled a bit. So there are two types of bar graphs. So there's what we call a vertical bar graph where the bars are upright, and there's a horizontal bar graph where the bars are horizontal, right? They are horizontal. Then we have what we call a pie chart. I'm not so sure why the Americans called it a pie. I think I think their pies are secular. You see, because when you talk about pies, our pies here in South Africa, they are not that, that shape. But I think in America, maybe their pies are secular. But here we can call it, let's say, a pizza chart, because a pizza is similar to this, right? So a pie chart is like a pizza, all right? Basically, what you're doing, you just want to use it where proportions are to be depicted relative to a whole. Let's say maybe, I'm not so sure if any of you are parents here, and if you have children. So let's assume that you're a parent with children, right? Let's say 3 children. You buy pizza, but pizza, when you buy this pizza, you know that the way these young kids eat pizza is different. This one has got a small stomach. This one has got a middle stomach. Then there's that one who has got a big stomach, right? Where they can eat a lot of, especially, when people are getting into their teens and things like that, they eat more. So what you want to do now, you would want to, let's say if someone is explaining to you, that pizza that you bought yesterday, is asking you a question, that pizza that you bought yesterday. So who ate a lot of slices, right? So when you are explaining it now, you are explaining the slices relative to the whole pizza. So that's the concept of a pie chart. So a pie chart, what you do is you want to explain data relative to the whole data. Like, for example, it's used to describe, let's say, demographics. Let's say someone was doing a study and then they were, let's say, male, female, and let's say maybe and other, right? So now when you are now displaying the data demographics, you say 30% said that they were female, right? And maybe you say 50% said they were male, and then you say 20% said they were other, right? So what you did right there is you have described the data relative to the whole population, right? So that's where a pie chart is used. So in essence, it is a circle divided into segments with the size of each segment proportional to the value of the variable, right? Relative to the whole, and is usually expressed in percentage terms. So let's look at an example right there. So consider a father who gives spending money to each of his 3 sons. So it's a father, 3 sons. So Josh is the eldest, gets 120 rand because he's the eldest, more responsibility, right? Then Matt gets 80 rand, that's the middle child. And then David, the youngest, you can't give a lot of money to the youngest one because they will not use it wisely, right? So gets 50 rand. So this data can be expressed in a pie chart as follows. So now that type of data now, we can depict it using a pie chart or a pizza chart, right? So what you want to do, how do you know now to divide this whole pizza into these different values there? So what you do is add the total amount of money that the father spent on all his children. So you take 120 that the eldest got, then you add it to 80 that the middle child got, and then you add it also to 50 that the youngest got. When you say 120 plus 80 plus 50, right, you get your 250 right there. Oh, okay. Let me just do this. 250 right there. All right. Yeah. So what you do now, basically what you do now is you want to display the percentage of the amount of money that Josh got in relative to the total amount. Because we said, remember, it's proportion that is depicted relative to the whole. So you are saying out of 250, Josh got 120. So what amount of fraction is it? So you say 120, that the amount Josh got divided by the total, you multiply by 100, then it's 48%. So it means out of 250 rand, Josh got 48% of that money, right? So you are actually explaining the amount that Josh got in relative to the total amount, right? Then you do the same thing for Matt, right? You say 80 over 250, then you multiply by 100, then you get 32%. You say 50 over 250 multiplied by 100, and then you get 20%. When you add all of this, it must give you 100%. Because when you say 120 plus 80 plus 50, it gives you 250. So you must get 100%, right? Because all the money, the total amount of money is equals to 100%. So now when you are drawing, so obviously you won't draw this manually, right? There are tools to do that. Excel can do that for you. If you just put in these values in some cells, Excel, and you tell Excel that I want a pie chart, it will come out like this, right? So this larger portion of the pizza slice, so this is Josh. So if it was that pizza, the issue of the pizza, it means that Josh ate all these slices of pizza, right? Then Matt ate all these slices of pizza. Then this one was for the youngest, right? So that is how you would depict, this scenario. So that's why I'm saying when you are displaying data, it depends with the type of data that you want to display. So you need to understand, is it demographics? Is it this type of data? Is this? So you choose the type of charts or tables to use based on the nature of the data that you have. All right. So I think this should be the last. So this should be the last diagram that we're going to look at. So there's something called a histogram. So when you're looking at a histogram, you think that it's a bar graph, but it's a unique bar graph. It's not just a bar graph, it's a unique bar graph, right? The first difference is you see that the bar chart has got gaps in between. Can you see? Right? The histogram does not have gaps. So that's the first thing. I remember last semester, the people that were doing statistical techniques, they were given actually, an assignment, and the lecturer wanted them to print a histogram. So if someone would have, let's say, generated a bar graph with gaps in between, it was wrong, even if the heights of the charts were correct, right? But they must be close together. Then histogram, it's only used, it's a bar graph that is only used to display frequency distribution. Remember that frequency table that we're talking about, right? If you want to display that table in a bar-like graph, that bar-like graph is called histogram. Remember the story, the example that we talk about 47 males that were grouped according to their years. So that is the representation of that same data. So instead of showing it in that table, someone could have shown it in a histogram, right? So remember, these were 12, these were 13, these were like 7, 8, 7, something like that, right? So this is the same data that we were talking about. Let me just show you a little bit for those that might have forgotten. Is this data there? So this data here, right, is being depicted as a bar graph. So if it's a frequency distribution related data, if you want to show it as a graph, that type of a graph is called a histogram, right? That's why it's not called a bar graph. It's not called a bar graph. It's called a histogram. So that would be what a histogram is. All right. So I think next week, let's start on this way we get to calculations now. This way it gets interesting and very, 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 very fun. Right? So I think for today, let's end here. I think this theory was enough. This is not all of the theory, right? There are some things that I left, but the reason why I didn't want to focus on that is because this, like I said, 98, if not 99% of the information that you write, either in assignment and in exam, right? It's mathematical, except the KCQ. But the KCQ, remember, we are, like James said, we are going to take you into that. So before you attempt your KCQ, we're going to have a class where I actually take you through each and every question of the KCQ. So when you actually log in to do your KCQ, you already have all the answers. So you're guaranteed to get 10 out of 10 because we We will give you each and every question. I think you have done it before. Do each and every question of the KCQ, and then we will show it to you. So if you didn't know, your final examination, it's multiple choice. I don't know if your lecturer managed to tell you that. So that's other one thing that I want to tell you. And I know right now it might seem ironic, right? But this is one of the most performing modules of ADBM. On all the modules that you have for ADBM, one module that you can easily get a distinction is this module, right? That's why I'm saying it sounds ironic because it's mathematical, but the method in which your exam comes now, it makes it that easy. You will see what I'm talking about when we get to doing some past exam preparation. So because it is, let's say, multiple choice, because I'm going to take you through all the formulas and all the units of mathematics, all the units actually, right? So it means that we would have done each and everything, right? So when the exam comes, right, all those things that have got, calculations and things like that, you will see that it's easier for you to pass them. Why? Because if you do it correctly, the answer will be there. So you don't guess. If you do it correctly, the answer you'll get there. And also, I'm going to show you later on that it will be very hard to fail this module because I think let me show you. Because you have 25 questions, right? That are multiple choice. It means for you to fail, you will need to get 12 correct. So you can't tell me that the whole examination you failed 13 marks. With all these lectures that I'll be taking you from now up until you write, it's very, very impossible. You will see when we get to the end. That's why I'm saying both of them, when I tell people this, when we start the module, they tend to doubt this. But when we get at the end, they will see that it's really, really possible. So it's one of the most performing modules that we have in ADBM. And I'll try by all means to make sure. I can say each and every person that will come through will be guaranteed a pass. Then what you are just fighting in the examination is getting a distinction. It's just getting a distinction. But I'm going to make sure that when we do the explanations, we'll explain it so well. And I'll give you there are some templates that I'm going to use that you're also going to use in the final examination. I'm going to give you templates and some certain websites where you can do calculations faster. Because what I don't want people that come through this module to do things manually. Of course, I'll explain it manually in the class, but I'll also, after I explain it manually in the class, I'll then give you the easier way. There's a saying where they say there are many ways of killing a cat, right? What we want in this module, we wanted the cat dead, right? Whether you kill it by shooting it, by drowning it, by choking it, we don't care. What we want is the cat dead at the end. So if the module is multiple choice now, it gives us now that opportunity of using various ways of killing the cat. So I'll give you the longer route, which will be the manual. Then I'll give you the faster way of doing it and the easier way for those that are lazy like me, who don't want to do a lot of things, strenuous work, right? We just want to get the answer that is correct. So there's a faster way that I'll also give you. Then after I'll give you those templates, I'll send them to you as a single document, and then some websites also that we're going to use when we get to probability. When we get to probability, there are some websites that are very, very easy. When you just put information, the answer comes there. But for today, I think this is good for a background. I'm not so sure if there are any questions related to what we were talking about. Just feel free and unmute if possible. All right. So like I said, okay.
Sorry.
Someone, yeah.
Oh, hello, sir. My question is I just want to figure out that is this module is all about calculations or
no, like I said, the module is not unit 1 and unit 2 actually they are theory, right? But
Okay.
like I said, yes, unit 1 and unit 2, they are theories. You remember when James was saying normally we take a bit of because it's calculations. I need to make sure that everyone is on board. So we tend to take more time in explaining certain concepts. So normally I start majorly with calculations. It doesn't affect. So the theory in unit 1 and 2 does not affect the calculations. It's just general theory. So I tend to start with calculations so that we cover a bit of ground. Then when we are done with calculations, we come back to unit 1 and 2. But in your examination, you rarely see a question for theory. You can have I think for the past, I'm not so sure if last year was there a theory question. I don't think so. I don't even remember the last exam that had theory. So that is one of the reasons why I don't start with theory, because I know that theory doesn't normally come. So I want to focus on things that are very major. But then when we are done with things that are very major, then we get into theory. And some of the theory also, don't worry, we're going to cover them when we do KCQs. KCQs are so your theory is covered in KCQs. That's what I can say. So we are going to explain now that theory in depth when we do KCQ. I don't know if I answered you very well.
Okay. Thank you.
All
Yes.
right,
Thank you, sir. Thank you, sir.
All right. Another question, guys? So from next week, when we start, don't just feel free to ask questions, even if you don't understand, right? Just feel free, because like I said, I don't like proceeding to a next concept without everyone aboard. Because the reason why you are coming through to VUT, you want us to assist you, right? So we are there for you. The reason why also we are starting now is so that we can cater for those things. So don't feel like I will not ask, because at the end of the day, we want you to get a distinction. That's what we want. Not only to pass, but to get a distinction. And I know you guys can get it, because our past clients have been getting distinctions. You can ask James, he can tell you in this module. So I know, so I would want each and every person, if they have a question, ask upfront, so that we can, if you don't understand, I'll take my time, then explain. When we are together now, we proceed to the next level until we finish the whole module. So I think if there are no questions, I think for tonight, I think that will be all. And thank you for coming through, choosing VUT. We'll meet in the next lecture. So James now will give you the timetable. We normally don't do Tuesday. It will be Monday, but same time. Monday, 7 o'clock, if it's statistical techniques, right? Tuesday, it's for information management for those that take that module. But for tonight, you guys have a lovely evening. Good night.
Good night.
Good night, Buddha.
Good night.
Good
night. Bye,
Good
everyone.
night.
Right,
Bye,
thank
everyone.
you.
In.
Oh.